Alright everybody, this is 7.2, Solving Systems by Graphing. So if we want to graph something, let's do a quick review on how to graph the two types of equations that we're going to be running into. So first off is we have linear equations. So this first graph kind of just shows you a reminder of what this kind of looks like. It's a straight line. It has a y-intercept, okay, at 4, and then it has a slope. Okay, so these are the equations, what they'll look like. Y equals mx plus b, that's the slope-intercept form, where m is the slope and b is the y-intercept. Okay, so if you remember how to do that, we start first by plotting the y-intercept. And then from there, we will use the slope, rise over run, plot points as we go along. We'll do an example of that in just a moment. Okay, the other type of equations that we'll run into are quadratic equations. All of these will be in standard form. Again, that's ax squared plus bx plus c. If we're trying to come up with our vertex, again, it's an x and a y. It's an ordered pair. If you want to find the x, it's negative b over 2a. Again, it's part of that quadratic formula that we talked about. We just plug in our a, and we plug in our b, and then we can simplify that to give us what x is, okay? And that will give you some sort of number. Once you have that number, then we can find our y. Again, if you have an x and you need to find a y, then we can take that number, that answer for x, and we can plug it into our equation and solve for y. Okay, and we'll do an example of that in just a minute too. Once you have that vertex, then we can just use our pattern. Again, if a is 1, then we'll do 1, 3, 5, over 1, up 1, over 1, up 3, over 1, up 5. If a is 2, then we double that, so it'd be 2, 6, 10. And if a is negative, then it's going to go down 1, 3, 5, or down 2, 6, 10. Okay, we'll do an example of that in just a minute. All right, and then just a reminder, we kind of talked about this in our previous lesson with solving systems by substitution, is that there will always either be no real solutions, and that's when the two equations, those two lines or parabolas, don't touch or cross. We could have one solution, is where it touches at one single location. Again, that's called like a tangent line. And then we could have two solutions. That's where the line crosses the parabola 2 times. Okay, so keep that in mind as we go along. This is just a quick reminder. You've done this before, I think in 9th grade. So if this is helpful, let's kind of start with that, and then we'll talk about how it's a little different. So again, we're going to plot these two linear equations. Okay, again, this is negative 1 over 1. If you want to write it as kind of like a rise over run, and then x plus 5. So again, this is our y-intercept, and then this is our slope, our rise over run. So we'd start by plotting the y-intercept as 5, and then its slope is down 1, because it's negative 1, so down 1 over 1, down 1 over 1, and would keep going all the way to the edge of your graph. And then this continues to go to the left as well. It should be a straight line. Connect your dots. Okay, and then that's our first equation. So on all of your problems that will come up in the future is you'll do one of those, and then you'll do a parabola. Again, we'll do one more example like we did last year. This again would be our slope of 2 over 1. So again, this is your m, and this is your y-intercept. Is negative 1, so we'll plot that negative 1, and then we'll go up 2 over 1, up 2 over 1, up 2 over 1, and go the opposite direction. Connect your dots the best you can. If you have a straight edge, that's awesome. That will always help. Okay, and then here, where they intersect, this is our solution. It is 2, 3. It's an ordered pair. It's where they intersect, where they cross each other. Okay, so that's what you did in ninth grade when you did systems of equations. Let's see how that's different when we get into 10th grade. All right, we'll start by plotting the linear equation. Again, how do we know which one's the linear equation? Well, the linear equation doesn't have the exponent. It's just an mx, it's just an x with no exponent on it, plus b. Okay, so again, we'll plot b, our y-intercept, so that's -2. And then our slope, again, is 2 over 1, so up 2 over 1. It's just like what we did on the previous page. Just had a different y-intercept. And we'll connect those dots. Sorry. Again, do your best. I'm trying to save some time on this video, but do your best, and because if you don't have your points in the right spot, then they might not intersect correctly. All right, so that's our linear equation. Let's talk about the quadratic equation. So again, we're trying to find the vertex, because that's like our starting point. That's kind of like the y-intercept for linear equations. That's our initial point for linear equations. For quadratics, vertex is our go-to. So we want to find our x. Again, that's -b over 2a. Again, I hope my b doesn't look like a 6. Had somebody do that. It's a b. Okay, so we've got -b, that's 2, over 2 times a, which is 1. Again, you could use your calculator if you wanted to. It's not too bad. It's just -2 divided by 2, which is -1. So that's the x for your vertex. And we want to find its y. So again, if we have an x and we need to find a y, then we can plug this x value into our equation. So we'll get y equals, use parentheses always when we substitute, so -1 parentheses squared plus 2 times -1 minus 2. Again, you could use your calculator here if you wanted to. It's not too bad though. I think this is just 1 and then -2 minus 2, which would give us -3. So now we have our vertex, -1, -3. We're going to plot that, so -1, -3, which would be right here. And then we're going to use our pattern. So here a is 1, so our pattern is 1, 3, 5. Again, it's always 1, 3, 5, but we just multiply it by whatever a is. So we'll go over 1, up 1, and we just hit one of our intersections, over 1, up 3, over 1, up 5, on both sides. Connect your dots. Oops, I probably want to be more careful when I do this part. Okay. So this has one intersection. I'm going to circle that. So this would be at 0, -2. So one solution. Okay. Again, you can do it this way every time if you'd like. We've also learned in the past how to graph from our last unit, how we can maybe find the vertex using our graphing calculator. So if you wanted to do it using your graphing calculator, that would be just fine. Again, just a little hint on how to do that again. So I guess let's graph the linear equation first. So this is going to be my linear equation. Again, if something's missing, you can always make it look like one of the other equations. So this would be -3x plus 0. So the y-intercept would be 0, and then has a slope of -3 over 1. So down 3 over 1, down 3 over 1, and then we'll go the opposite direction to connect those dots. Okay, so now let's talk about if we wanted to use our graphing calculator. I'll probably do it, most of the time I'll do it just by doing it algebraically by hand, but you are welcome to do this with your graphing calculator. So if we want to do it by graphing calculator, okay, then of course we would do y equals, and we would type our equation into your graphing calculator and push graph. Okay, you've done this before, but just in case by chance you forgot. Okay, so once you do that, you push graph, you'll see the graph, and then if you want to find the vertex, again we would go and press second and then trace, and then you need to choose if it's a max or a min. So if I remember, I might have this backwards, but I think number 3 is min and number 4 is max. So for this example, you could look at your graph and it's going to be doing something like this. So we're going to have a max. So we would choose max. And then it will give you the instructions: left bound, enter, you'll push enter, right bound, enter. So again, if you have more questions on that, again, we have this little cheat sheet that we used in the past, and then would push guess, enter. And that would just give you your vertex. Okay, so you're welcome to do that. Again, I'm going to just do this really quickly by hand. I didn't bring my graphing calculator with me. So here we'd do our vertex, again, is an x and a y. That's negative b over 2a. So that's negative 4. Okay, watch that. A lot of people forget that. Over 2a. Over 2 times a, which is negative 1. So again, this is a equals negative 1, and b is negative 4. And I think that ends up giving you 4 divided by negative 2, which is negative 2. So we end up getting negative 2, comma, and again, to find the y, we just plug it into the equation. So we'd have negative 2 minus 4 times negative 2, and then plus 2. Sorry, I'm kind of running out of room here, am I? Give me one sec. Plus 2. So this should give you negative 4 plus 8 plus 2. So I think that will end up giving you 6. So that would be our vertex. It would be negative 2, 6. And then our pattern here, a is negative 1, so we'll go over 1, down 1, over 1, down 3, over 1, down 5. And we'll do it on the opposite side. So over 1, down 1, over 1, down 3, over 1, down 5. If you can do 7, like over 1, down 7, you should do that. And there's one on your homework, perhaps, that if you only do 1, 3, 5, then you're going to miss one of your intersections, one of your solutions. Okay? So here we have our 2 solutions. One is at negative 2, comma 6, and then the other is 1, comma negative 3. So we have 2 solutions. All right, so we have these other 2 examples. Let's do F for sure. I'll probably do, oh my gosh, the letters are like way off. This is B, C, A, F. That's weird. Okay, I should probably fix that. This would be C, and this would be D. Okay, so we're going to do D for sure because this equation looks a little different perhaps. And then if you feel like you want the extra practice, do C with me in just moment. All right, so let's talk about our linear equation first. Again, linear equations don't have the exponent, so this is our linear equation. Again, we can make it look like mx plus b. You just have to figure out, is the 4 the slope or is 4 your constant, your y-intercept? So here it's the 4 is our y-intercept, and the slope is 0. So slope of 0 is like a horizontal line at the y-intercept of 4. So it should look something like this. Okay, we'll do the other equation. Again, you're welcome to use your graphing calculator to find your vertex. But again, I'm going to have some extra practice here for me. So we've got x equals negative b. So that's negative 4 over 2 times a, which is negative 1. And that should be 4 divided by negative 2, which is negative 2. Which is, I think, the same thing we got up here. It is. That's funny. Okay, and then we'll want to find our y value. So we're going to take this negative 2 and we'll plug it in. So we'll have negative 2 squared minus 4 times negative 2 plus 4. Again, we have negative 4 plus 8 plus 4, so I think we end up getting 8. So that's our vertex, would be negative 2, 8. And then we'll use our pattern. So here a is negative 1, so we'll do 1, 3, 5 going down. So over 1, down 1, over 1, down 3, over 1, down 5. And then I think we could do 7. So 1, 3, 5, 7. Connect those dots. And those would be our solutions. So we've got negative 4, comma 4, and we've got 4, nope, sorry, got that one wrong, 0, comma 4. All right. Okay, well, I'm going to do C. If you want to go along and do that with me, that's great. If you feel like you've got it, awesome. So again, we're going to start our y-intercept at 1. Rise over run is 2 over 1. Gosh, I have a lot of those. Probably need to fix that up too. Okay, connect those dots best you can. Again, you can use your graphing calculator if you'd like to find your vertex, or we could just do it by hand. So vertex is negative b, so negative 4 over 2 times 1. So we end up getting negative 2. What's that other one too? They're all like negative 2s. Oh, my word. Okay, it's not like that all the time, okay? It's just so happened that Mr. Warner probably didn't look into it too much. All right, and then we'll plug these in. Again, please use parentheses. Please be careful if you're going to do it by hand, or if you use your calculator, I guess. Just be careful. So this should be 4 minus 8 plus 3. So I think that gives you negative 1. So that's going to be your vertex, would be negative 2, negative 1. And then our pattern is, again, A is 1, so it's 1, 3, 5 going up. 1, 3, 5. 1, 3, 5. Connect your dots. Ta-da! So for this example, we have no solutions. Or at least no real solutions. Okay? All right, well, if you have any questions, please just let me know. Again, I have these notes are filled in on Canvas as well if you need it. Sometimes I put in a little extra when I do my notes, so if you feel like you're not quite getting it, you can always go to there and see if that's helpful. All right, we will see you later.